Rosemary Ngoli. I'm very happy today to have been invited for this meeting. I am working with International Lies Research Institute. Currently, I am based in Tanzania, but I am Kenyan, so it really gives me a pleasure to be here today. Currently, I am based in Tanzania, but in about 2 weeks, I will be relocating to Becker, Biosciences for Eastern and Southern Africa at the EU campus. However, I still continue to take the responsibility of the breeding activities in Tanzania. So I'm going to present to you what we are doing, specifically not in Kenya per se, but what we are doing within Eastern and Southern Africa, and especially Tanzania, we have been working, and the activities with which we've been collaborating with NIB, NIAD, Haero, CARI. Thank you very much for this strong collaboration that we've run, which started in 2011. And I'm very happy to share with you that yesterday a new variety was released in Kenya, even in less than 2 years, which is really, really a great achievement. So the title of my presentation will be EU Collaborative Lies Research Activities in Eastern and Southern Africa, the achievements we've made, the challenges we've had, and our plans in the next 3 years. As part of my presentation, I'm going to talk about the lice situation in Eastern and Southern Africa, the breeding activities we've run in Eastern and Southern Africa, other activities apart from breeding, since mostly we've been working as in breeding activities, the challenges, the next steps, and a brief summary. I have to mention that in ESA we are working in 7 countries: Rwanda, Burundi, Uganda, Kenya, Tanzania, Malawi, and Mozambique. And lice research activities in Eastern and Southern Africa started from Mozambique. That's where we had our first office in 2008. In 2009, we started an office in Tanzania and also in Burundi. But still, other countries that we don't have an office per se, like Kenya, we've been collaborating with the national partners and National Irrigation Board. Importance of lice has been emphasized by most of you, and you have to know that currently in 4 countries, Kenya, Uganda, Tanzania, and Mozambique, we are importing lice worthy $400 million. So it's really, really important if we can be able to reduce this. And in Eastern and Southern Africa, the largest producers are Madagascar, which produces 2.6 million tons, Tanzania 1.3 million. However, production is really low. Like in Tanzania, we only get 2 tons per hectare. And from previous presentation, you've noted that consumption has really increased in Africa by 34%, in Tanzania by 32%, and someone mentioned in Kenya by 12% annually, which is really, really high. So if we can be able to increase the productivity of lice by tapping the large, vast area and also expanding our irrigation program, I believe Africa we can stop importing bad lice import from Pakistan, from Asian countries, and we can even be able to export our lice, our good lice. As part of the breeding activities, what we'll be doing is evaluation of and selection of the new breeding lines. And mostly the materials we've found have been coming from EU headquarters, and also from SIAT in Colombia, because they have lice research activities, and also from Africa-wise. We've been sharing these materials with our national partners, and like most of you, like CARI, they have been coming to for these meetings that we've had. We've also participated variety selections with the farmers. We've been purifying and multiplying our existing and also the new varieties. And currently we've started our hybridization program where we are trying to improve our local varieties. So I will show you, so you can see from here the different types of germplasm we've been importing from EU headquarters, SIAT, and Africa-wise. Like the salinity materials, like in Tanzania, we have a big problem of salinity, so we've been putting them in saline conditions and checking them there. We've had some local cultivars that we've been collecting and also trying to check them, because you realize the importance of our local cultivars. And some of these are really valuable genes which have not been exploited. As part of the importation of the varieties, I have to mention that in Tanzania, this year, we released 2 varieties, IR05N and IR038262, which was compared by Saro 5. Saro 5 is a variety that probably most of you know. It's really grown widely in Tanzania. However, it is low yield and is susceptible to most of the diseases, and also has a lot of breakages, as in the milling recovery is very low. So these 2 varieties were released in Tanzania early this year. And as I mentioned yesterday, the National Release Committee in Kenya, collaboration with CARI and Ksms, they released IR05N221, which has higher yield than the Saro 5 that was compared with. It is aromatic and is very good for both rainfed and lowland conditions. All the national partners in the countries we are working in, they sent us the germplasm, the materials that they are growing there, and we had 1 trial in Aero in collaboration with Aero Irrigation Scheme and 1 trial in Mian. And this was done in 8 countries, and altogether we had 18 sites. Data has been analyzed, and we have also done some quite intensive quality analysis of these varieties, and the report will soon be shared with the collaborating partners. And as you can see, this is CARI, this was in Aero last year, and this MET, regional MET as we called it, has provided a very good platform in that we are able to share the germplasm from the different countries, the good germplasm that they are growing in those countries. And this is how we came to the variety that was released yesterday, because when it came, it was evaluated, then Ksms took it under 1-year MPT, and yesterday was released. So these the MET trials in Kenya and other countries. This was Zanzibar, this was Mozambique. And you can see from the MET trials, I mentioned we had 26 varieties in Czech, and these are the materials that were advanced in Kenya. And currently, this season, we are going to do an advanced in trial where we are going to put them in the replicated trial in the 2 sites that we have, so that we can check the adaptability to the different ecologies. We've also been inviting the different NAS partners, the CARI people, where they come, and we select from the materials that we import from the other countries. They come, and we have a workshop where they come and they select the materials. That's the thing can be adaptable to their countries. And after they select, we send them the germplasm, then they evaluate them. And this has provided a very good platform for breeders in that we can be able to share the progress, the different problems we are having, and see how we can help each other. And I have to mention, this is not only for Eastern and Southern Africa, but even people from West Africa come and they are able to select the materials that we have. 2011, we had it in Tanzania. Last year, we had it in Uganda in a private company, which was very, very good as we think of how we can work with the private companies, especially in the seed industry. Yeah, last year, we had it in Tildo, Uganda, and we had 3 people from Kenya. They selected 58 germplasm, which have been cleared now by Ksms, and they will be planted the current season. During our selection, like the way we did in Tanzania, we invite the farmers in the varieties. After we do the advanced intrants and the replicated intrants, farmers come and they move through the varieties and they select these varieties. After they select, we help them cook with our national partners, cook the 2 best varieties they select, and they check that they grow within the legend. And the farmers can be able to rank the rice varieties, because we understand that even if a variety can be good in the field, if it is not tasted, as one of the farmers was saying, it's very, very important that the farmers get to cook this rice and taste it themselves and recommend it. Because if it's good and high yielding, if it gives me 7 tons, but if the farmers cannot eat them, the millers, they will not even be able to mill it. The farmers will not be able to buy it. They will not be able even to eat it. So it's very, very important. And I also have to mention that among the farmers that we invite, 30% has to be women, because we realize the role of a woman, especially in the kitchen in our African setup. This is the sensory evaluation where we cook and then they come and they taste.
What will happen if you become minister for gender?
Okay, another thing we've been doing is purifying the local jamplers. Like I put a case of specifically for Tanzania, because when I went to Tanzania 3 years ago, they had collected one of the variety called super. I think most of you have heard about the super variety. It's very, very good. It's very tasty. And there were 86 supers. And the question we asked, if we have to do a breeding program, which super is super? Which super can we use? Among the 86, we're trying to narrow down through morphological markers. We planted them in the field, and we eliminated, and we are left with 46 supers. But still with 46 supers, we cannot call them all supers. So what we did, we used molecular markers, and I have been working closely with Becca because that's where I also did my PhD, but it was a collaborative project. So we did the morphological characterization where we used molecular markers, the 50 GCP markers, to be able to eliminate the super, so that we were left with a true super, so that we can be able to start our hybridization program. And also we involved the national partners to be able to really tell us what is the real super. So we've compared the morphological markers and the molecular markers, and there's a paper on that that is underway. We are waiting for the next season of the morphological markers, and then we'll be able to compare so that we'll be able to eliminate all the duplicates of supers. I have to mention that Erie has the biggest gene bank for lice germplasm. And what we did also, we got the 15 supers from Erie. And we realized even what Erie had kept as supers, some of them were not supers, they call it supers. Another activity we've been involved in is nutrient breeder seed production for the release variety. But these we produce, especially the breeder seed for the national partners. As you realize the law of Erie's law is not to release the variety, but releasing the varieties lies with the national partner. And we work very closely with the national partners. Like now, after the variety was released, I was talking with John, and we are going to send them some little breeder seed which they are going to use for multiplication, pure breeder seed. So we've been producing nuclei as a breeder seed for the varieties that have been released. So I've talked about the super characterization, and from these pictures you can see these are supposed to be super, and this is the true super. And you can see even from the picture, like a picture itself is not the real super that the farmers were calling super. So these we've been doing using the molecular and morphological markers, as I've mentioned, and from this you can see like some of the supers, these are still called supers, but you can see the super bad. This is a parent. This is a real true super. You can see some of them are, they don't have the super bad. So in that we've been able to eliminate the supers. After we purifying the supers, what did we want to use the super because it's a very important variety in East and Southern Africa, especially Tanzania and Mozambique. We crossed it with a line ILBB because bacterial leaf blight is a big problem in this country, and we already have a population that is now in BC1F4 in Tanzania, in Mozambique, and Burundi. And we will be continuing to evaluate those materials, and hopefully in 2 years we'll get a variety released. So this marker, I heard somebody was talking about the aroma gene. We have the aroma marker, the BADH gene. We've been able to check our population to be sure that at least it has the aroma gene that we are looking for. Other activities we've been involved in is capacity building. We realize the importance of especially pure seed, because even if you have a variety, you don't have a clean seed, the pure seed of it, the 2-2 type seed, we cannot move fast. So we've been training farmers, progressive farmers, such as technicians on pure seed production. This we've also been doing in Kenya. This was in Kenya in Moya, and in collaboration with MIA last year, where researchers were trained. Also, we have a lice knowledge bank. However, I have to mention that for Kenyan one is handled, but you already have for Tanzania, where all the information about lice is Kari is working on it to have a lice knowledge bank, whereby researchers, technicians can be able to access all the information they want on lice online. Also, we have weather stations involved, especially in sites where we've had activities before. However, in Kenya we've not had that, so probably in future we might have that. Another thing I have to mention is that all the sites where we are having trials, we run our soils characterized. And this is easily available and doable. Like in Moya, we have the soil characteristics. And as long as you install the Google Earth, you will be able to log. I can send you the KMS file. You will be able to log in and get the soil characteristics of all the sites that you are working in, which is very good. Instead of repeating this soil analysis again, this can be easily accessible. So we also have PhD and MSc trainings going on. There's one student currently who is working in Hello, in Mwea, and in Mombasa. Because a big problem we realize is the material that we get from housing. We get them here, they can do well here, but after a short time they break the resistance. So what we've been doing, especially for glass and BLB, we have one student who is trying to characterize using molecular markers the pathotypes that we have in different sites. So what we have recombinant green lines, which we planted in Mwea, in Nairobi, and Mombasa, is going to sample all the brass isolates we have, and we are going to characterize that. Also, from the recombinant green lines we have, we will be able to tell which gene is resistant and which can work in the different locations, which is very, very important because we can use our own genes, our pathotypes that are available here to develop our own varieties. Challenges, capacity building, which especially on seed production, we are still having that. However, more people need to be trained. Another challenge I find is that this picture, I took it in Ahero, where you find that most of the farmers are burning the straws. This is in Mwea, where people are really, the farmers are really utilizing the straw. Another thing we've been trying to do is to have small machineries. We try to do that in collaboration with Kali, and they're trying to replicate the small machineries that we find in Asia. However, I have to mention a big challenge personally I see, especially in the region, is seed production, marketing. How do we get our seed, the varieties that are being released, getting to the farmers? How do we involve the private sector also in this? Okay, I'll skip that because of time. Okay, talk about this. Summary. We have really a huge potential to increase rice productivity in the region because we have the area, we have the waters, we have the people. So we should become an exporter of rice in the next couple of years. We have a variety testing network. We have very good collaboration with the nurse partners, with the research organizations. So we should be able to get our varieties to these people. We have varieties that have been released, and some others are in the pipeline. Local varieties have been purified, which can be used in the future breeding programs. We have what we did, we have asked the different collaborators, what are really the varieties that people like in their regions. And now we are trying to do a variety profiling, where we know that what products do these people want. If aroma is a big key in Kenya, why don't we target that? So that when we are improving our varieties, we know that we have the key traits in them. And also we have already 10 MS and PhD researchers who have been already trained, and who are really able to take up and enhance our collaboration. Thank you very much. I have to acknowledge IRI, NAS partners that we've been working with, Tanzanian government, me and NIB, thank you very much.